Okay. 9. Did we do 9? Let's see. So let's see. Yesterday we did 2, 1. We tried 14. Didn't work. 13, 17, 4, 5, 6, 7, and 8, right? So you guys want to work on 9? Okay. Let's see what we have for 9. All right, so 9, we're supposed to do the limit comparison test, which is the yellow sign up there on the board. All right, so number 9 says that we have the sum as n equals 1 to infinity of 4 over the square root of 5n to the 8th plus 8. So for the limit comparison test, we're supposed to find something to compare it to, right? So the easiest thing to compare to is if I can turn it into some kind of a p-series, okay? So we're going to start with the limit as n approaches infinity. You take your original function, and that goes on the top. 5th root of n to the 8th plus 8. All I'm going to do is I'm going to drop the 4. I'm going to keep this 5th root of n to the 8th. Okay? Because technically the 5th root of n to the 8th is really 1 over n to the 8/5, which is what kind of series? P series. Okay. With p equal to what? 8/5, which is greater than 1, and when p is greater than 1, does it converge or diverge? Converges. Okay. So I also now need to look at these limits here. Okay. I am going to choose to flip and multiply. So the limit as n approaches infinity of 4 over the 5th root of n to the 8th plus 8 times the 5th root of n to the 8th over 1. Okay. If you look at it, really we have this, right? And we have this. And if you look at these exponents right here, aren't they the same? Yeah. The limit as n approaches infinity. So all we have to do is look at the number in front, the coefficient, which is 4. So our limit, because this is like last year's limits, right? Not this year's, but last year's limits. It's just that the exponent looks funky. All right? So when we are greater than 0, we know they both what? Converge or diverge. And in this case, because the p-series converge, we know this one also converges. See, there's one that didn't diverge. All right. What else do you guys want to talk about? 10, and then which one, Keely? 18? Okay. Okay. 10 says that we have, which series below should be used in the limit comparison test to determine whether the series, the sum as n equals 1 to infinity of sine of 5 over 7n converges or diverges. Does this series converge or diverge? Okay. So they want to know which one we need to compare to. All right, what did we see here? So the first one in part A was 1 over 7 to the n. Is that even remotely close to what we have there? No, so I probably wouldn't use A. B has something to do with cosine of 1 over n. I might not eliminate that one quite yet. This one says 5 over 7 to the n power. Is that what this says in here? No, so I'd get rid of that one probably. And then D says compare to 1 over n squared. And E says compare to 1 over n. None of them are remotely close, are they?
No.
All right. So when all else fails, we could this is the best one to go to because it's pretty generic. Okay. This one, because it doesn't match closely enough in there, that one's got a funky squared on it. At least this has the n in the denominator. So the correct answer is supposed to be E. This one is not on the test. Okay. At least I don't remember it being there from looking at it 10 minutes ago. So, okay. Hopefully I'm right. All right. What else do we want to talk about? Oh, 18. That's right. Okay, so 18. We have to use the ratio test. And make sure you know both the ratio and the root. The root is on the free response for sure. Okay? I was just looking at it. So the sum as n equals 1 to infinity of -1 to the n minus 1 times 9 over 5 to the n over n squared. Okay, and we're supposed to use the ratio test. If we look, I know the ratio test is kind of hidden up there right now, but the ratio test automatically puts absolute values around things. So do we need to really worry about this piece? No. Okay, so I'm going to ignore that piece. And we're going to do the limit as n approaches infinity. And I'm not going to worry about the absolute value bars. I know once I take the absolute value, it's going to be positive. All right. And the first thing we have to do is plug in an n plus 1 to anywhere where there's an n. And then we're going to divide that by the original function the way it looks. Over n squared. Okay. Next thing I am going to do, okay, is I am going to probably distribute this in, okay, and same thing here. At the same time, I'm going to flip and multiply. So we still have the limit as n approaches infinity of 9 to the n plus 1 over 5 to the n plus 1 divided by the n plus 1 squared times n squared on the top, 9 to the n over 5 to the n. Okay, if you look at what's going on here, technically isn't this going to cancel with that? That 9 to the n is going to get rid of that 9 to the n, right? And I'm just left with 9. And the 5 to the n should go with that 5 to the n, and it gets rid of the 5. So we really have the limit as n approaches infinity of 9/5 times n squared over n plus 1 squared. Now we're back to last year's kind of limit. Technically, what's the highest exponent in the denominator? N squared. So the exponents match, so what does the limit have to be? 9/5. We're greater than 1. When it is greater than 1, it diverges. It's kind of hidden behind the screen there, but it diverges.
When you got rid of the n, you got rid of the whole thing, not the n on the right side, just the n on the left side.
Yeah, because so it's really doing this. We're subtracting the exponents. So these guys would cancel, right? Because it's a division bar, so subtract your exponents, right? Back to algebra 2. Okay. All right, we all good with that one?
Wait, did you cancel just the ends?
Yes, just the ends. The 9 to the first stays, and the 9 to the and the 5 stays.
So what happened to the 9/5 on the bottom? The 9
It was 5 to the n.
Yeah,
So that whole thing went. It's this concept right here. If I have that as my top exponent, and then we have the division bar, I'm going to subtract the bottom exponent. Those go. The 1 stays. Same thing with the 5. We've got 5 to the n plus 1 on the top, minus the exponent of n on the bottom.
Yeah, but what happened to like the 9
Yes, to the n.
Well, yeah, like I see that you cancel out the ends, but what happened to the 9 on the bottom? So we didn't do that. It just like
It has an exponent of n. It goes away. What happens when I do this? don't I subtract my exponents? And the 1 and the 10 in the denominator goes away, right? It's the same concept. Okay? All right, what else? 11. Okay. All right, we're supposed to decide about the alternating series test on this one. So 11. It says we're considering the series the sum of n equals 1 to infinity of negative 1 to the n over the natural log of n plus 2. Okay? And it says we are supposed to be deciding about the alternating series test. It gives us some answer choices. It says diverges, can't be applied. Still diverges. Okay. So, the very first thing that we have to look at is the limit as for what? Alternating? It says that we have to look and see if the limit equals 0, right? So the limit as n approaches infinity of the series, and I get to ignore the 1 in front, right? So we're doing the natural log of n plus 2. We have to decide what that ends up equaling. So technically when I put in the infinity, we get that, so it equals what? 0. So that part of it checks out. That's the first part of alternating series. We know that the limit is equal to 0. The second part says we have to prove that it is a decreasing function. Okay? So, I'm ignoring the negative because it's alternating. We know that. But we have to make sure that the terms decrease. So we've got 1 over the natural log. When I put in a 1, we get the natural log of what? 3. And then we get 1 over the natural log of 4. And then 1 over the natural log of... We don't really have any concept of what 3, 4, and 5 with the natural log do, right? So this is best to put in your calculator. So right now I need you to calculate 1 over natural log of 3, 1 over natural log of 4, and 1 over natural log of 5 to determine whether or not it's decreasing. So get me the decimals. 0.91. Point what? Point. Okay, so do we agree that it's decreasing? Yeah, so therefore we know it's decreasing. So if it is, so according to the alternating series test, all we have to prove is that it converges if it limit equals 0 and it's decreasing. So is it converging or diverging? We know it's converging. Okay, converges. So if I look at the answer choices, it should be answer choice E, right? Because 11 says E converges, and that is the correct answer. Awesome.
It's when the bottom number gets bigger, that's when it's big.
Correct. And the bottom number, the bigger the bottom number, the smaller the overall. Okay? Okay, anything else you want me to talk about from this? 12? Okay. Alright. Doesn't look like I have number 12. So, similar to this one. Oh, you know, we looked at this one last night. It's got a sign in it, right? This one's not on the test. I'm going to tell you that right now. Okay? But because we've got a sign on it, it's not on the test. Okay? It's really funky looking, but because we've got a sign in it, sign goes up and then down and up and then down and up and then down and up and then down, right? So it really doesn't, it's really hard to tell what's going on with it. So I think it's one that cannot be applied. Let's see, 12 says D. We know that it can't be true, thank you. For all, because you can't apply the alternating series test because we can't prove that it's always or that it's decreasing. Because a sign is going to make it go this down here, and then up here, and then down here. Does that make sense? So this one should have been answered. It was, I lost it. D, right? So I'm not worried about you knowing that one. You can cross that one out. Okay? Okay, what else do you guys need to talk about? 13? 15. Okay, 15 is a good choice. I remember explicitly seeing that one. So, all right. 15, we're supposed to determine if it converges absolutely, conditionally, or diverges. So we've got n equals 1 to infinity of negative 1 to the n over n to the 2/7. Now, we would probably start by thinking alternating, but alternating isn't where we get the conditional and absolute from, okay? We get conditional and absolute from either the ratio test or the root test. So I would probably go for the ratio test. What did I do? I didn't even do that. I did alternating. I don't know why. I know. Okay. Well, let's try the ratio test on it, okay? See what happens. So we've got the limit as n approaches infinity. Okay. We have to add the plus ones. Do I need to worry about the alternating piece of it? No. So we got 1 over n plus 1 to the 2/7 power, which was the plus 1 part, and then over the original. Okay. And then I know I've got to flip and multiply, so limit as n approaches infinity. It's going to bring this up to the top, isn't it? N to the 2/7 over n plus 1 to the 2/7. I know why I did the root at this point. Does it exactly equals 1, doesn't it? Because ultimately, what's the exponent going to be on this n? Okay, so it means that it's inconclusive at this point, because on the ratio test. So that means I can go back and you look at one of the other tests to see if it does converge by one of the other tests. If it converges by one of the other tests, then it converges conditionally. Okay, so what would our other favorite test be? Alternating. So we're going to go now do the alternating series test. Okay. And the first thing we have to check is to see if the limit of the original equals 0 without the negative 1. So we've got 1 over 2 to the 7th. When I plug the infinity in, what do we get? 0. Good. Okay. And then the second thing we could look at is if it is a decreasing series. So we put 1 over, what, 1 to the 2/7, which is just going to be 1. 1 over 2 to the 2/7, probably need my calculator. Okay. And then 1 over, what, 3 to the 2/7. So plug in your calculator, see what kind of decimals you get. 0.82, what's the next one? 730. Okay, so is it decreasing? So we know it's decreasing. So we know that it converges by alternating series, right? So therefore we would say that it converges conditionally. Conditionally. Okay. Yes. Because it didn't pass the ratio test. Okay? In order to, if you look up at the poster at the board, you might not be able to see it because the thing's blocking it, but it says that it has to be less than 1 on the ratio test. And we got it exactly equal to 1, which means it's inconclusive. Okay?
They're decreasing from the right to the left, right?
From the left to the right, yeah, it has to be going down. That way. Okay?
If you do 1 divided by 0.82, it's 1.21.
Are we sure that it's 1 divided by 2 to the 2/7 is 0.82? I assumed they gave me the final answer when they did the 1 divided by. So let's go here, scratch pad. Oops. So control divide 1 divided by 2 to the 2/7 power.
That's the only thing they want us. Okay, so you're saying.
Okay, makes sense?
Yeah.
All right. Yeah, it wasn't just the denominator they were giving me. All right. Are there any others that you guys would like to look at?
Can we do 20?
20? Sure. Okay, let's look at 20. We have to decide on the root test. Oh, you're not going to like this part. Okay, so we've got the sum as n equals 1 to infinity of 8n plus 1 over 3n minus 1 to the n. Okay. So on the root test, we're supposed to take the limit of the square root of that thing, or the nth root of that thing, sorry. So the limit as n approaches infinity of the nth root of 8n plus 1 over 3n minus 1 to the n. What's the nth root of something to the n power? What's inside, right? It cancels. How nice was that? All right, what do you notice about the exponents? They're the same, so what's your limit? 8 over 3, which is greater than 1, so that means it diverges. $16? Okay, 16. Oh, we still got lots of time. Ratio test. So we got the sum as n equals 1 to infinity of n times 10 over 9 to the nth power. Okay. So ratio test says, I'm going to skip the absolute value part, so the limit as n approaches infinity. I'm plugging in the n plus 1 into it first, so n plus 1 times 10 over 9 to the n plus 1 over, you guys, let's pay attention. Okay. So now what I'm going to do is I'm going to flip and multiply at the same time. I'm going to go ahead and distribute this in, okay, on both of these. So the limit as n approaches infinity of n plus 1. Really, couldn't I just leave this the way it is? Yeah, so that's going to just stay the way it is, okay? I'm going to leave that alone, okay? Then I've got times 10 to the n plus 1 over 9 to the n plus 1. We're going to flip and multiply this part here. Times 9 to the n over 10 to the n. It's the same concept we were talking about a few minutes ago. This is a fancy division sign. When we see a fancy division sign, we are allowed to subtract our exponents. So 10 to the n plus 1 minus n really becomes what? 10. So I'm going to do 10 times n plus 1 there. All right, and then same idea here, only I'd be subtracting going down, right? Yeah. So what do I really end up with in the denominator? 9n. What do you notice about the exponents? They're the same. So what's my limit? 10 over 9, which is greater than 1. So let's see, this was the ratio test. When it's greater than 1, it diverges. I don't know why a lot of them came out diverges. It was just what the test generator spit out. So I'm not going to tell you that because there is no guarantee what the test generator spit out. I didn't look at the answers on the test for tomorrow. I only looked at the problems. All right. Are there any others that you're confused about that you would like to see? I don't know. I have not been keeping track. 19? Nineteen is identical to 20. Yeah, I am recording them. I am going to try. For some reason, stuff is not uploading to my computer at home right now. So, like, the stuff for the Dropbox didn't appear last night. So, I'm going to try to do some of the rendering here, but... Okay, so root test. It's identical to what we did on the other one. The limit as n approaches infinity, you take the nth root of something to the nth power, right? What happens with these guys? This is almost better than the ratio test. 6 over n, 5n plus 1, so my limit is 6 over 5, which is greater than 1, which means it diverges.
I'm just gonna put diverges.
What?
It's nice when it's set up like this for the root test.
Yes, well, we don't want it any other way for the root test, right? Hopefully we'll get lucky and it'll be set up like that on the test.
All we have left is 21 to 24.
21 to 24.
Yeah.
Okay.
21.
21. Alright, let me look really quick. Which one is the most important of the four? I know that there's one on. Alright, I think we should do 24. 24. Okay. The other ones, yes, you need, actually 20, if you look at 23, 23 is a really bad question. Yeah, because it's got a negative exponent. You could move it to the top, but it's supposed to be a P series, and we can't move P series to the top. So I think that 23 is a bad question. So you can cross 23 out. Okay? All right, let's look at 24, because that's the one that is the most important one for the actual test. Okay? Let's see what we can do with it. So 24 says that we have the sum as n equals 1 to infinity of 9 over n times, or over, sorry, 9n times, or over n plus 5. So if we look at the choices that we have, okay, we've got the ratio test, the nth term test, P series, and integral test. And it's either got to be P series with integral test or ratio with nth term if it turns out to be one of those, okay? Let's try the nth term test first, okay? So nth term just says we have to take the limit of it as n approaches infinity of the exact function, and we're hoping that it comes out to be 0. If not, it diverges. So what is my limit there? 9, right? So does it equal 0? So does it converge or diverge? Diverges. So we know that it has to be either just B or it has to be A and B, which meaning it's E. So I should check the ratio test. Okay? Does that make sense on what we got to do? So you have to first of all decide if it converges, diverges, and then you know which other one to check. Okay? So I'm going to check the ratio test. I got the limit as n approaches infinity. I've got to put the n plus 1s in over n plus 1 plus 5. That's looking weird, right? And then over the original, the way it looks. So here's the issue with the ratio test. Up here, do you see how we're getting n plus 6? when I go to flip and multiply, it's not like it's a factorial. There's not going to be any way for me to cancel. Okay? So the ratio test really just doesn't work for it. Okay? I mean, we could keep going on it. We could probably still get something for it, but so the ratio test ends up being inconclusive, because isn't it gonna? I think it ends up being 1, isn't it? Because 9 over 9 ends up being 1 on the ratio test. So it's inconclusive, meaning it's only B. It just diverges by B. Okay?
Wait, if it were to equal 0 on the Nth Term Test,
Then it converges. Only if it equals 0, though. Okay? Alright. So let's see. 21. Okay, so I'll really quickly try to run you through 21 and 22. Okay? So 21, we had sum equals n equals 1 to infinity of negative 1 to the n times 7 over 5 to the n. Our choices were alternating, integral, ratio, and integral. Okay? I'm going to go ahead and go with the alternating to start, since it looks alternating. Okay? So alternating first says find the limit, see if it equals 0. So limit as n approaches infinity of 7 over 5n. So what's that going to end up being?
0.
It ends up being 0. So does the first part work? Yeah, okay, so now I have to check and see if the terms are decreasing. So 7 over when I put in a 1, I get 5. And then 7 over when I put in a 2, we get 10. We put in a 3, we get... Is it decreasing? Yeah, so we know that it's converging or converges by alternating series. So we know that it's definitely A. Okay. Then it says it could possibly converge by the integral test. I know that's one of our favorites. The integral test says, first of all, it has to be positive. Okay. So does it come out to be... It's a positive series. I think that the negative knocks it out, doesn't it? Its terms are decreasing. Oh, but we would have to look at the limit as... It's this test, right? 1 to infinity of this thing here. Right? And then we do the limit. Did we go this far last night? I don't remember.
No, we just like talked over it.
We talked over it, but when we said that it was because it wasn't it's not positive because it alternates. Because you can't ignore the alternating when you do the integral test. Does that make sense to everybody? So because it alternates, can't use integral test. Okay. So it's just A. All right. 22. This is a good old P series, it looks like, right? So sum of n equals 1 to infinity of 3 over n. What's your P? 1. So when P is equal to 1, does it converge or diverge? Diverges. Okay, so we know it has to be A. It could possibly be C and A, though. So we could use our integral test. Is it positive?
Yeah.
It's continuous. Is it decreasing? So 3 over 1, 3 over 2, 3 over 3. Is it going down?
Yes.
Okay, so we know that it's positive decreasing, so we would have to do the integral of 1 to infinity of 3 over n. Sorry, 3 over x, right? We switch it to x's. And then we do the limit as b approaches infinity of 1 to b. I'm going to put my 3 out front. When I integrate that, what do we get? Natural log. So we've got 3 natural log of x from 1 to b. Then we've got the limit as b approaches infinity of 3 natural log of b minus 3 natural log of 1. That's 0. When I put infinity into here, what do we get? Infinity. So does it converge or diverge? It has to diverge because this diverged, right? So it diverges. So so it has to be both A and C, which makes it answer choice E. Okay, that was it, right? We covered almost everything. All right, so remember Thursday, your study-a-thon paper's due. Tomorrow you have a test. I'm not going to collect your notes tomorrow.
I did mine.
Great, I'm happy for you.
She only does them every day, so. So what?
And Keely has a good grade in the class. What do you know? Think there's a correlation?